So today we're going to be looking at solution sets to equations. Now there's two main types of solution sets, but these solution sets, discrete or continuous, we're talking about types of functions. So we really need to start off with, well, what's a function? So if we come over here, it says a relation is a, wait a minute, what's a relation? Yeah, we should probably start there. So relations, they're just sets of ordered pairs. There's no rhyme or reason, there's no rules, it's just a bunch of x's and y's. So a bunch of ordered pairs. It could just be generic, it could be for a particular scenario. So the relation is just a group of ordered pairs. Now, again, no real rules here, as long as we have some sets of x's and y's. For it to be a function, each of those x's has to have exactly one y. Now, our x values, let's think about that. When we have an equation, our x values, if we have an x and a y, if we go to plug in, we input our x values to find out what the y values should be. So x's are always our inputs. So a relation is a function as long as each input has exactly one output. Okay? So relations, again, they're just sets of ordered pairs, but for a relation to be a function, each input has exactly one y. So x's are not allowed to repeat, okay? Because they've got to have the same y. Now let's look at a couple of examples and kind of see how these discrete and continuous functions, what the difference is. So it says for the following scenarios, first it wants us to create an equation. Okay, we can do that. Find 3 possible solutions. Okay, and then create a graph. Awesome. I think we can handle this. So first, let's start off by creating our equation. So let's go ahead and look. It says Sydney is shopping for art supplies at Michael's. Ooh, I can get in trouble at Michael's. Paint is on sale for $3. Canvases, we're going to change that to $5 so we have an easy number to work with. If Sydney has a budget of $30, what possible combinations of supplies can she purchase? Now, let's go back to our directions. It says create an equation. Because this scenario could definitely be an equation or an inequality. Because does she have to spend all 30 of those dollars? No. But for what we're doing right now, it says to create equation. Okay, so we'll start there. So first, what's the first piece of information? She's shopping. Cool. All right, what are we buying? So paint is on sale for $3. Canvases, we changed that to $5, and she's got a budget of $30. Okay, so paint is on sale for $3. So $3. Cool. Am I just spending $3? I don't know. It depends on how many paints we buy. So $3 per paint. So 3P. We're also spending money on canvases. So we've got an additional $5 per canvas. So 5C, 5 for each canvas. All right, so far I have created an expression. Now, it said to create an equation. So how much is her budget? We want to know what will equal $30. So since we're solving an equation, we want to know when we're coming up with our 3 possible solutions, what's going to make her exactly spend $30. So there's lots of different combinations, but when we're trying to make it exactly 30, that's definitely going to get rid of some of those possible combinations. So paint. When I'm looking at possible combinations, so I'm going to pick P as my input and canvas as my output. Doesn't really matter which one in this scenario because neither one of them is a true input. Like sometimes you have, in other scenarios, there is something that must be the input because one thing depends on the other. We're going to talk more about that in a minute. But here, when we're just purchasing two different things, it doesn't really matter. So usually just whichever item comes first, we make that our X. So paint is going to be our input. So if we've got $30 to spend, what is the maximum number of paints we can buy? So let's see. We got 30 bucks to spend and paint's $3 each. Well, 30 divided by 3. Maximum I could buy 10 paints, but I would have no money left over for canvases. Does that make sense? Now, what would the maximum number of canvases we could buy if we didn't buy any paints? So again, if it's $5 per canvas, 30 divided by 5, I could have a maximum of 6 canvases if I bought no paint. Now, why did I do that? Because I'm looking at the max. What's the maximum number of paints I could buy? What's the maximum number of canvases I could buy? And then from there, we can find some other pairs. So when I set up, I know I have one more to find, but I just want to start off by looking at my graph. Like, let's set it up and see what it's going to look like. So we chose for paint to be our input this time. So on my x-axis, I'm going to label it paint. And we only have a maximum of 10, so I think we have plenty of room here. So I'm just going to go ahead and number by ones. 1, 2, 6, 8, and 10. Sorry, apparently Jolene thought that she needed to be part of my video today. Okay, so maximum number of paints we can purchase, 10 paints. All right, now I'm going to do the same for canvas. So my canvases, we had a maximum of 6, 2, 4, 6, so 0, 6. Okay, so now we just need to find one more pair that's going to give us $30. So let's see. Well, 15 plus 15. So how many paints would I purchase to get $15 worth of paint? So 3 times 5. So 5 paints. And then to give me another 15, 5 times 3 canvases would give us a total of 30 bucks. 3 times 5 is 15. 5 times 3 is 15. So 5, 3. That is going to give us another data point. When you are looking at a graph, up until this point, most of the time when you're given ordered pairs, you've been taught to just go ahead and connect them, right? Do they make a straight line? Yeah, so I connect them. No, that is not why. There is a reason behind whether we connect our points, okay? So this is where it comes into play. Is this a discrete or a continuous function? So can I buy, it's just focus on the X's. Can I buy 2 cans of paint? Sure. Can I buy 3 cans of paint? Sure. Can I buy 3.1675 cans of paint? Yeah, I'd like for you to go up to the person checking you out and say, excuse me, can I have 3 tubes? And I would just like 12/100ths of that tube, please. Yeah, they're going to look at you like you got 3 heads. It's not happening. So we can't buy a partial can of paint. So that makes this a discrete function. So we have discrete functions. So we do not connect our points. They are just individual points because we can't buy partial paint. I'm saying containers because I don't know if this is, cans or tubes or spray, who knows. So that's what makes something a discrete function. If you can't buy a partial, can't have a partial. So let's look at this next example. So Trenton, all right, Trenton, what y'all got going on? So Trenton's family, they're on a road trip. Awesome, traveling at an average speed of 75 miles an hour. So it wants us to find the average distances they could travel in a day. Okay, so that Are we giving enough information? Let's go back. Let's mark the text. So, on a road trip, cool beans, not going to help us write an equation. So we're traveling at an average speed of 75 miles an hour. Okay. That's not much. So it wants us to find the average distances. So find the average distances they could travel in a day. How do we find average distance? So hopefully this is a formula that you guys remember. When I see distance, what's the distance formula? D equals, let's see, what do you remember? D equals, Jolene, R times T. Sorry, apparently the rain has got her all kinds of crazy today. So D equals R times T. Distance equals rate times time. If you didn't remember that that's what that stuff stood for, you might want to make yourself a little note. Distance equals rate times time. Okay, so if we're given the average speed, what part of this formula is speed? Is speed the distance? No. Is speed the time? No, it's the rate. So let's go ahead and plug in 75 for our rate. And, well, it wants us to find the average distance they could travel in a day. So we're looking for the average distance. We're going to solve for D. And we don't know time because we don't know how many hours have we traveled. Now, when we're going to find our ordered pairs, it only wants 3. What we need to think about is who is the input and who is the output. So, phrase it in a way asking who depends on what. Does the distance depend on the time or does the time depend on the distance? So the distance we travel, does it depend on the time we travel or does the time we travel depend on the distance? Wait, no, that sounds funky. I think it's the first one. The distance depends on, well, how long we've been in the car. That makes sense. So T has to be our input, okay? T is our input, and depending on how long we've traveled, that will tell us how far we've traveled. So, let's see. I'm just going to go ahead and start with easy because I'm multiplying by 75. So if I have traveled 1 hour, how far will I have traveled? Well, 75 times 1 gives us 75. So 1 hour, we should have traveled about 75 miles. What about 2? 2 hours, 2 times 75, about 150 miles. All right, assuming we don't have to take any bathroom breaks, let's figure out for 3 hours. So 3 hours, another 50 gives me 200, so 225. Okay, so when I go to set up my graph, again, who is our X? Who is our input? So the input this time is time. Okay, so how long we are traveling depends on how far we travel. So that's our distance, our Y. So obviously we're not going to be traveling forever. It really is just talking about a day. So I'm going to go ahead and split this up so I have some room. So 1, 2, 3, 4, 5, 6. I just need a few points. And for distance, I'm going to make it super easy on myself. And since we are jumping up by intervals of 75, I'm going to number by intervals of 75. Now, let's assume that we have not started driving. So if we have driven 0 miles, and how far will we have traveled? Sorry, if we've traveled for 0 hours, how far will we have traveled? 0 hours. Okay, so that's where I'm going to start, 0, 0. Because if I haven't gone anywhere, no time has passed, we can't travel anywhere. I don't know why I'm having such a hard time saying that. So if we've traveled an hour, we should have gone 75 miles. 2 hours, 150. 3 hours, 225. So 4 hours would be 300. Now, let's figure out, is this discrete or is it continuous? So how far have I traveled? Can I figure out how far I've traveled in an hour? 2 hours, 3 hours, yes. Can I figure out how far I've traveled in an hour and a half? Yeah, plug in 1.5. Can I figure out how far I have traveled in 1 hour and 12 minutes? Sure. I could even figure out how far I've traveled in 1 hour, 12 minutes, and 37 seconds. I could. It'd be a little obnoxious, but I could. So since we can find all those little bitty hours, all those itty bitty intervals, this is continuous. And since it is continuous, we can connect our points. Oh, that's off a little bit. Try again. Move line. Oh, internet, why are you so delayed? Thank you. Whew. So this would be a continuous function. Because we can find the distance of partial hours. We can find the itty bitty intervals. Okay, so hopefully that helps you guys to see the difference between discrete and continuous functions, and we are going to continue to work on this a lot in the next unit. Okay, see you soon.